Today we'll be discussing the yard bots, which are an automated landscape system of robots. For our problem statement, we felt that consumers need an affordable, time-saving way to maintain their lawn because lawn care is expensive and time-consuming. There should be more time for the joys in life. Swarm of robots that can work together simultaneously to allow people from all walks of life to enjoy their lawn is the ideal solution. Our target customer base would be the approximately 40% of Americans who would otherwise spend their money hiring landscape contractors, yard owners that currently service their lawns but want to save themselves the time and effort, and other potential stakeholders for the product could include lawn care professionals themselves who could supplement their own services. For our design requirements, we had multiple requirements for each of the robots that we had in the system. This included our sweeper robots, our mower robots, our edger, and hedge trimmer robots as well.
The Create and Conquer Yard Care Swarm consists of 4 robots, each of which docks with and is launched from a central hub. Each robot communicates with the central hub throughout their work. The first of these robots is the Sweeper Bot, which utilizes motorized brushes installed along its undercarriage to sweep up debris from the yard both before and after the other bots have done their work. This debris is collected in an attached bin, which will be emptied when filled. The robot utilizes distance sensors to avoid overlarge obstacles and IR sensors to navigate yard boundaries. The second member of the swarm is the Mower Bot, equipped with a set of rotating blades fixed on the undercarriage, which it uses to mow the lawn. Debris is ejected from the rear to be picked up by the Sweeper Bot later. This robot is also equipped with distance and IR sensors to navigate around obstacles and yard boundaries, respectively. Next, we have the Edger Bot, which is designed to trim the hard-to-reach grass that grows along yard edges. The robot does this using a side-mounted rotating blade, utilizing distance sensors to avoid obstacles and to stick within yard boundaries. Finally, we have the Hedge Trimmer Bot, which is responsible for trimming the sides and tops of bushes. This is accomplished using a rotating blade attached to the top of a set of telescoping limbs that can raise or lower the height of the cutting blade. This bot also utilizes infrared sensors to restrict itself to within yard boundaries and distance sensors to properly position itself while trimming.
Now, all of these individual robots work together by hooking into docking stations, which are all connected to a central hub. When the user starts the program, that central hub will initiate each robot type's tasks in order, one at a time. Now, once initiated, each robot works independently, relying solely on its sensory input and internal timer in order to determine how it carries out its tasks and how it returns to its dock. Now, all of the docks are set up along the edge of the lawn or at the end of the hedge and then hooked into the central hub. The central hub will send out a signal to all robots of a single type, which will all be initiated at once to carry out its tasks. Once all of the robots of that type are finished with their tasks, they'll all return to their docks, which allows the central hub to initiate the next batch to accomplish their tasks. And this will go on until all robots have completed their tasks. Now, in order to succeed, all of the docks need to be positioned at the edges of the lawn or at the end of the hedge. All the lawn boundaries need to be well defined, and there needs to be minimal obstacles getting in the way of each robot. A significant point of failure is anything that can stop a robot from returning to its dock. For example, if there's a hole in the lawn boundary, that can allow a robot to escape the lawn and have a hard time pathing back to its dock.
The budgets for the prototypes are seen on the screen here. And the average cost of a market-ready system would be about $1,100 for all 4 bots total. This is based on competitive pricing of replacement blades and motors and parts for existing motors, as well as the average cost of already existing products of the same variety, and then the idea of 3D printing most of the casings with polycarbonate.
For the entrepreneurial aspects of the yard bots, there was a previous idea that existed for lawn care robots, but that idea is bulky and slow. The yard bots are quick, efficient, and compact units. The yard bots are designed with the consumer in mind. They're designed for the average homeowner and to be mostly hands-off. The yard bots overall are the consumer's choice when it comes to automated landscaping. They're cost-effective, they're easy to use, and they can be used commercially if so desired.
In summary, our lawn bots are a full-service lawn care system that takes your hands off and saves you some time and money when you're taking care of your lawn. They're a competitive market rate, and there aren't many product competitors out there at the moment. Engineers definitely need a group perspective and different experiences to put together a project like this. We probably should have worked together a little more and thought of like our combined effort and bigger picture. Here are the references we used